says define the term limiting reactant. Okay, now again, like I've said before in my previous lessons, whenever they ask you to define something, they're basically telling you that that's what we're going to have to work with. So it says define the term limiting reactant. Well, limiting reactant is the reactant that basically restricts a reaction, restricts the amount of product that is formed, but it runs out first. Okay, that's what happens, the limiting reactant. Now it says iron and sulfur react together to form iron sulfide according to the following balanced equations. They've balanced it for us, which is nice. It says calculate which of the two substances will be used up completely if you've got 20 grams of iron and 10 grams of sulfur are mixed and heated. Okay, so theoretically we've got 1 mole of iron reacts with 1 mole of sulfur to form 1 mole of iron sulfide. So the ratio here is 1 to 1. So what we need to do is find out how many moles we've actually been given of this. So the number of moles of Fe equals the mass over the molar mass, and the mass we've been given is 20, and if you look on the periodic table, the Fe is 56, sorry. The molar mass of Fe is 56. So we can pop that in our calculators, and we can say 20 divided by 56 equals 0.36, 0.36. So that's the amount of moles being given of the iron. Now let's look at sulfur. Again, the number of moles of sulfur is equal to mass over the molar mass, and we've been given 10 grams of sulfur, and the molar mass of sulfur is 32. So we're going to again use our calculator, and we're going to go 10 divided by 32, which is 0.312. So it's 0.31. So now, do you see that the ratio was 1 Fe to 1 S? Okay, that means when I use up 1 mole of iron, I'm using up 1 mole of sulfur. We are given 0.36 moles of iron, and we're given 0.31 moles of sulfur. So do you agree all the 0.31 moles of sulfur is going to use up 0.31 moles of Fe and leave 0.05 moles of iron left over? So it says calculate which of the two substances will be used up completely. Your sulfur is going to be used up completely. Okay, how many grams of the other substance are in excess? Well, we've already worked out we've got 0.05 moles. Okay, that's the moles. So to find the grams is very easy. All we have to do is multiply by the molar mass. So the number of the mass, grams, equals the number of moles, which is 0.05, times 56. And now we're going to have to get out our calculator. So we've got 0.05 times 56, which is 2.8. So we're left with 2.8 grams of iron. Okay, and that is in excess. Right, let's delete this and move on to the final question of this presentation. Now it says magnesium burns in air to form magnesium oxide according to the following balanced reactions. Very nice when they do that. So if the percentage yield of the reaction is only 80%, calculate the mass of magnesium that needs to be burned to produce 30 grams of magnesium. Okay, so we want 30 grams. We want 30 grams of magnesium oxide. Okay, magnesium oxide, that's what we want. So do you see that the ratio of the moles is 2 to 2? Okay, right? So if we work out this number of moles, and then we can work out that amount of moles, and then we worry about the 80%. Okay, so the other way of doing it is working out what it should be. If we can say, okay, well, 30 grams equals 80%, okay, then do you agree that 30 times by 100 over 80 is going to tell us what the theoretical yield is? The theoretical yield. It's probably easier if we do it this way. So let's do that. Let's find out what a theoretical yield was. So we've got 30 times 100 divided by 80 equals 37.5. So theoretically, we should have got 37.5 grams of magnesium oxide, but we only formed 30. But it doesn't matter. We're going to use this 37.5 to work out how much we should have burnt, okay, to get that. Right, so we're going to say, well, it's 2 moles of magnesium goes to 2 moles of magnesium oxide. So what we need to do is convert this 37.5 grams into moles, because this is a mole ratio. It says 2 moles of magnesium theoretically is required to form 2 moles of magnesium oxide. So let's do that. And again, like I said, you need your periodic tables out. So number of moles is mass over molar mass. The mass is 37.5. The molar mass of magnesium oxide, magnesium is 24.3 plus oxygen, which is 16. So now we need to pop that in our calculator. So we go 37.5 all over 24.3 plus 16, close bracket, equals, and that's 0.93 moles. So that's 0.93 moles. So we have formed 0.93 moles of magnesium oxide, but the ratio is 2 to 2, which means that it's 1 to 1, which means that if we formed 0.93 moles of magnesium oxide, we have to have used 0.93 moles of magnesium. So therefore, the number of moles of magnesium is 0.93, that's magnesium. The molar mass of magnesium is 24.3. Therefore, we can work out the mass that is required, because calculate the mass by using number of moles is mass over molar mass, where the number of moles times by the molar mass is the mass. So the number of moles is 0.93, times by 24.3. So let's just pop that in our calculator. So we've got 0.93 times 24.3 equals 22.599. Remember, we always round this up to 2 decimal places, but this 9 is going to push that up to a 0. So this becomes 22.6. So we need 22.6 grams of magnesium to produce 30 grams of magnesium oxide. Right, and that's how you do this question. Please, grade 11s, again, if you don't understand what's going on here, go back to the section that this is talking, have a great day.